Dear students, now let us see the next topic, which is the energy possessed by body, which is in SHM. So before going ahead, let me have a quick revision of what we have studied. We have studied that a body which is in SHM is governed by a force law, which is equals to F is equals to minus kx. Don't be confused that we are using this formula for spring also by Hooke's law. Yes, it is also there, but here we just derived that F is equals to ma, and a value is omega square x. If we come and if we write m omega square, we replace by k, then we find that F is equals to minus kx. So here omega comes out to be root k upon m, right? Now what I am going to do is, if someone asks you a question that you are given a spring connected with the mass m, and what is the time period of oscillation, sir, we will use this formula, again this formula for SHM, and this formula also by Hooke's law, because Hooke says that restoring force is directly proportional to negative of displacement. We know this box is in SHM. I can this is the governing restoring force formula. If I compare, or if I see both of these two are similar, I can say I can use this k and this k to be the same for this case only. Then I will write here the angular frequency of oscillation comes out to be k upon m. Similar to this above equation, I can write here, because if you compare this minus kx and is equals to m a is nothing but omega square xt minus omega square xt, then minus cancel out each other, xt cancel out each other, you get omega is equals to root k upon m. So time period of oscillation t is equals to 2 pi upon omega, and omega is nothing but k upon m, so t is equals to 2 pi root m upon k. Now what is the second question which can be asked is, if it is the block which is connected between the two springs, and these springs, one end of the spring is attached to the fixed wall, one to the end of mass m. These are kind of two springs, one of whose constant is k1, spring constant is k2. Dear students, don't be confused that we are using this k for what. See, we are using this k for force constant in SHM, as well as we can use this k for spring constant. Force constant and spring constant both are different, but we are using the same formula because this is governed by the Hooke's law, and the same is governed by the SHM force law which we have done. Both gives the same but value, but they both are different. Here the what is the net force experienced by this m? Let us come back to the question. What is the net force experienced by this m? Is, sir, force due to F is equals to minus k 1 x distance is same, जितना इसमें compression हुआ उतना इसमें expansion हुआ होगा, and force due to this spring 2 is minus k2x. What is the net force? You just directly add them and you will get net force is equals to minus k1 plus k2 into x. And if I compare this with F is equals to ma, a is minus omega square x cancel out each other. I am writing here t, for example, at any particular time, then omega comes out to be minus and cancel out each other. Similarly, we are doing the same. M omega square is equals to k1 plus k2, then omega comes out to be under root k1 plus k2 upon m, Then what is the time period of oscillation? T is equals to 2 pi upon omega. Omega value is root k1 plus k2. So k1 plus k2 in denominator and m in numerator. If k1 and k2 both are same, then it is 2 by root m upon 2k. Okay, now let us come on to the next topic, which is the energy in SHM. How much is the energy stored by the body which is in SHM? It is equals to the sum of potential plus kinetic. Potential is given by half kx square. Kinetic is given by half mv square. X is the displacement, instantaneous displacement at particular instant. V is the instantaneous velocity. Let me recall the equations of displacement equation. A cos omega t plus phi. In terms of cos we are taking. We could also take in terms of sine. So Vt is differentiating above equation. Omega comes out. Cos is minus sine. Omega t plus phi. I should write here minus sine. Now sir, the potential energy is given by half kx square. If you write half k as it is, potential energy k is here constant, so x value is a, so square cos square omega t plus phi. Let me write here equation 1. Similarly, the kinetic energy is given by, for a body is in SHM, k is again a constant, so half mv square and half m as it is, and v velocity is what? Minus omega a. So it comes out to minus minus plus omega square a square sine square omega t plus phi. If I find out total energy E is equals to kinetic energy plus potential energy. The kinetic energy is nothing but this half m omega square a square sine square omega t plus phi, and potential energy is what? Half k a square cos square omega t plus phi. Sir, I think we can put the values of k or m omega square because both are same. So I can write half k a square common outside, and inside it will become sine square. I am writing only theta because omega t plus phi is theta, I am assuming, and it comes out to be 1 because by triangle identity sine square theta plus cos square theta 1, the total energy comes out to be half k a square, which is constant because k is constant, a is constant, a is maximum displacement. So this curve shows that the total energy possessed by a body in SHM is constant. Kinetic energy decreases, potential energy increases, and vice versa. You already studied in your previous classes. Now let us come on to the next and last topic, which is the simple pendulum. A simple pendulum is nothing but a system wherein you take a very lightweight and a thread, and you tie a bob with a thread. Then what happens? This thread is inextensible. Let us suppose this thread is tied to the wall of and one end of the thread is attached to the mass m, and let us suppose this mass is displaced from the mean position by an angle theta, and the mass comes here. What happens? The mass is having tendency to come back to its original position, and it will not stay here, it will move further, and it reaches to the another extreme position. Again what happens? The mass, this will move to and fro about the fixed point. It is called the simple harmonic motion. I am going to find out the time period, which you all know, t is equals to 2 pi root L upon g. How it comes? Before that, we have to assume that this string is massless and inextensible. Then only we can find out the proof. The only way is very simple way to find out it is you just know the number of forces acting over it. So there are two forces. One is the tension in the string, and another one is the acceleration due to gravity, mg x downwards. We take components of mg. If it is theta, it is also theta. So let me again draw this figure here, neat and clean figure, and do it again. It is my fixed wall. It is the bob of mass m displaced by angle theta. It is the length of the string L, and here the string is attached to the bob. The bob is having tendency to return back, and the forces acting on the mass m are tension and g downward. We take component of g, mg, parallel to the string mg cos, because if this angle is cos, this angle is also cos, and the perpendicular component is mg sin theta. Dear students, इस बॉब की टेंडेंसी है कि ये रोटेट कर रही है, मूव तो कर नहीं रही, आगे तो बढ़ नहीं रही, ये रोटेट कर रही है एक पॉइंट के अबाउट। तो इस पॉइंट के अबाउट ये रोटेट कर रही है, तो रोटेशन होगा, इसका मतलब टॉर्क होगा। अब टॉर्क दो फोर्स हैं, एक एम जी कॉस और एक एम जी साइन। कौन दे रहा है? एम जी कॉस और टी मिल करके, मतलब नेट फोर्स दो हो गए। अच्छा, इस लिसन इसमें वी कैन से there are two first acceleration. One is the radial acceleration and second one is the tangential acceleration. Radial acceleration is nothing but the centripetal towards the center, toward along the radius it is acting. So radius acceleration is offered by this t minus mg cos theta along this radius, because mg का आप कंपोनेंट ऊपर की तरफ लोगे तो t माइनस एम जी कॉस थीटा हो जाएगा। एंड टेंजेंशियल एक्सेलरेशन इज प्रोवाइडेड बाय एम जी साइन थीटा। सर यहाँ पे जो अगर मैं टॉर्क निकालूंगा तो द टॉर्क एंड वी आई वांट टू फाइंड आउट द टॉर्क अबाउट दिस सपोर्ट। मैं अगर इस पॉइंट के अबाउट टॉर्क निकालूँ, इस पॉइंट के अबाउट टॉर्क, ठीक है, इस सपोर्ट के अबाउट टॉर्क, तो मुझे कैसे टॉर्क पता लगेगा? फोर्स इंटू फोर्स आर्म। अब इस पॉइंट पे फोर्स लग रहा है टी माइनस एम जी कॉस थीटा, और इसी पॉइंट से डिस्टेंस, तो पैरेलल हो गया, कोई टॉर्क लगेगा ही नहीं। लेकिन अगर मैं इस फोर्स की वजह से इस पॉइंट के अबाउट टॉर्क निकालूंगा तो मुझे इजीली पता लग जाएगा, क्योंकि फोर्स आर्म तो हो गई ये, ओके, और फोर्स हो गया मेरा ये एम जी साइन थीटा। सो आई एम फाइंडिंग आउट द टॉर्क ड्यू टू the tangential force is force into force arm, mg sin theta into force arm is length of the string L. I am taking here minus n because the torque is having tendency to bring back to the original position. It is not increasing the angular displacement, this torque is reducing the angular displacement, so I am taking tau as negative, is reducing angular displacement, so it is taken to be negative. Now see, टॉर्क आ गया, टॉर्क आने से मैं इसको क्या करूँगा, आई अल्फ़ा यानी एफ इक्वल टू एम है, उसी तरीके से टाउ इक्वल टू आई अल्फ़ा के इक्वेट करके अल्फ़ा यानी एंगुलर एक्सेलरेशन पता करूँगा, और एंगुलर एक्सेलरेशन अगर डिस्प्लेसमेंट के नेगेटिव की डायरेक्टली प्रोपोर्शनल आता है देन इट इज़ एस एच एम। तो next what I have to do, let me move ahead with the next new pages. So we know tau is equals to I alpha, equating these two, I alpha comes out to be minus L mg sin theta, and here alpha comes out to be m g L upon I into sin theta, which is of minus sign. Sir, this sin theta can also be written as theta for theta small, for small theta sin theta is equals to nearly equals to theta. So alpha is equals to minus mgl upon I into theta. So this is whole is constant, L constant, G, M, I all are constant. Moreover we have seen, ये तो एंगुलर एक्सेलरेशन है, अभी हमने पिछली क्लास में, अभी पिछले उसमें देखा था कि लीनियर एक्सेलरेशन होती है L a is equals to minus ओमेगा स्क्वायर इंटू एक्स टी, थीटा इज ऑल्सो द फंक्शन ऑफ टाइम बिकॉज नॉट फिक्स्ड। अगर मैं इससे को कंपेयर करूँगा यहाँ से, तो ये मेरा ओमेगा स्क्वायर की वैल्यू क्या आ जाएगी, mg L upon I. I hope these all stuffs is very clear to you. Okay, so omega is equals to under root mg L upon I. This will give you the answer. अच्छा, यहाँ पर अगर जब आप इसे ओमेगा से रिप्लेस करोगे तो अल्फ़ा हो जाएगा माइनस ओमेगा स्क्वायर थीटा, और यहाँ पे ये रिप्रेजेंट कर रहा है कि अल्फ़ा एक्सेलरेशन नेगेटिव ऑफ डिस्प्लेसमेंट के डायरेक्टली प्रोपोर्शनल है, तो इसका मतलब ये SHM में होगा। अच्छा, टाइम पीरियड का फॉर्मूला t इक्वल्स टू 2 पाई अपॉन ओमेगा एंड यू पुट द वैल्यू ऑफ ओमेगा एज mg L अपॉन आई। सर आई तो मोमेंट ऑफ इनर्शिया होता है, और आई को क्या बोलते हैं हम लोग, ml स्क्वायर mr स्क्वायर, यानी ml स्क्वायर अपॉन m है, ये कैपिटल की जगह स्मॉल कर लेना आप लोग इसे, mg L m l cancel out each other and it remains as t equals to 2 by root L upon g. This is a very famous formula to find out the time period of a simple pendulum. I hope these all stuffs is clear to you. Thank you.